Hello, everyone. Uh, we're back again with AWS Data Dive focused on DynamoDB this week. I'm your host, Jason Hunter, a principal solution architect on DynamoDB. And we're talking about security and some of the features that DynamoDB offers to help you do more secure access control and networking control. And so I wanted to start this week with Ashwin Venkatesh, who's a senior product manager with DynamoDB. And my first question for you, Ashwin, is when we start looking at security with DynamoDB, how do we approach that?
Thank you for the introduction, Jason, and a very warm welcome to all our viewers here. So I'm Ashwin Venkatesh. I'm a Senior Product Manager for Amazon DynamoDB, leading the security and manageability spaces. So Jason, to your question, I'd like to start by saying security is our topmost priority. And the way we look at security is really in two ways. One is
Mhm.
preventative security, and the second is detective security to deliver value to our customers. And deep diving into preventative security, what we're really focused on is enabling our customers with solutions to help them protect their DynamoDB resources or data within those resources, or ongoing efforts to simplify access control to those resources so that our customers can enhance their security posture with DynamoDB. On the detective security angle, we're focused on helping our customers with auditability of their configuration, monitoring usage on an ongoing basis, classifying resources efficiently so that they can simplify the overall experience for cost allocation and billing, and a lot more. The common denominator, though, I wanted to state is we're constantly inventing and simplifying for our customers in these areas. And that's been a very rewarding exercise for us to just imagine the value that we're delivering to customers and what they can do in terms of addressing their use cases.
So preventative would be make sure you don't let someone access what they shouldn't. Detective would mean, I suppose, if someone did, you'd know about it, but also maybe in advance detecting, like, okay, there's a possibility that this would be public access. You didn't want that. Don't allow it. I see that
Exactly.
sometimes, right? All right.
Absolutely. That's well said. So the detective angle is both proactive and reactive, as you rightly put it.
Mhm.
Proactive so as to alert customers that they've probably got too much of permissions within their access
Right.
control definition, which they can
Right.
afford to constrain even further for least privileged permissions. And the reactive part of it is giving them the necessary tools such as logging, alerts, alarms, notifications, and monitoring capabilities so that they can effectively take action.
Right. So we've been doing some new feature releases lately in the security area. Do you want to give us a quick high level overview?
Certainly. Yeah. So these have been really exciting security launches, but let me start by saying the last few years, we've had the opportunity to engage with a number of customers across different industries, financial services, fintech, insurance, media entertainment, retail, and others. And it's been a really great learning experience for us from our customers in terms of what's top of mind for them in the security space for their day-to-day DynamoDB workloads and what drives their needs. So some of the common themes that have generally come up in our discussions are, hey, can you help us simplify private connectivity from our hybrid solutions, from remote
Uh-huh.
networks, private on-premises networks, or cross-regional traffic to DynamoDB? Can you
Sure.
simplify access control for us? Because a lot of customers have rapidly growing organizations where their teams are continually expanding, their app portfolios are expanding, and with that rapid growth comes a challenge. And here's the challenge. You have thousands of users and roles, job functions within the company. And how do you efficiently manage permissions on a day-to-day basis, right? And reduce administration overhead in the process? Because
Sure.
workload isolation becomes a challenge as companies are rapidly growing. And so from that viewpoint, they've asked us, can you simplify access control for us? And one of the common themes across any ask has been at the forefront, which is help us continue to maintain compliance, right? Whether it's with new or existing compliance programs or new corporate governance requirements. And so we've listened very carefully and really thrilled to announce that 2 months ago in March, we announced PrivateLink and resource-based policy support for DynamoDB. And so PrivateLink now, the first feature, and by the way, we launched this on consecutive days, as you might recall. And
Yeah.
PrivateLink, right? That's pretty cool. Simplifying private connectivity from on-premises solutions or for cross-regional traffic to DynamoDB. And
Mhm.
the experience is kept really simple because all customers have to do is create PrivateLink endpoints, capture the URL, and link that up to their applications. That's all there is. They don't need proxy servers. They don't need firewall rules to be configured. And so they can really continuously maintain compliance and enhance their security posture with DynamoDB.
Yeah, this is something you could do before, but it was a pretty long recipe. It was baking a cake from scratch where you start with grinding your own flour, and now it's in a box.
Exactly. It's in a box, as you rightly put it. So it's really private connectivity simplified for on-premises traffic or cross-regional traffic. The second is the very next day we announced resource-based policies for Amazon DynamoDB. We heard our customers ask for simplified access controls, including simplifying cross-account access control. And we responded with resource-based policies because resource-based policies now enable customers to set up permissions at the individual DynamoDB resource level, such as for tables or streams. And the permissions that you set up for a table cover the access control for the indexes associated with that table too. So customers can now manage the permissions for each resource at a single location, which is at the per resource level for a table or for a stream. And they don't have to proliferate and manage permissions across multiple user or role-based policies. It does give them the flexibility to use both if needed, right? For cross-account access control, which is also hugely simplified with resource-based policies. It's really trimmed down from a multi-step configuration process to just 2 steps, if you will. And so we, as an extension to that too, simplifying access control aside, we also have integrated with AWS identity services like IAM Access Analyzer and Block Public Access to really help our customers conform to least privilege within their policies, because least privilege is a core security tenet, and also help prevent public access to their DynamoDB resources. So we're really thrilled.
That's the detective part.
The detective part,
right? Exactly. So I can now grant access on a resource of who should see it, but also block public access will understand if I'm doing something more visible than I intend, and if I go public, it'll say no.
It will not allow you to even create a policy, so it nips it in the bud and kind of forces the admin to define a policy that sticks to least privilege principles and has a defined zone of trust, if you will.
So I couldn't even do public access if I wanted to. If I try, it'll say no, which good. That's the right answer. All right, so we have 2 things which you could kind of do before, like you could always do identity-based policies, but now it's easier with resource-based policies. You could always do cross-account, but you had to assume a role, and again, it was kind of a fairly 5-step recipe to get it done, and now it's kind of a 1-step recipe. And then with PrivateLink, you could set up a proxy and do some technical network management yourself, but now it's easy. So we took things that people were doing for security and just made it so that it's easy and approachable for everybody.
Exactly. Right? We've simplified security controls by closely listening to our customers.
I like it. All right, I think we should deep dive on these things.
Let's do it.
Yeah. So for a deep dive on resource-based policies, I want to bring in Aman Dhingra, who's a senior solution architect with DynamoDB, my peer, who's really been working deeply in this area. Let's bring on Aman. Hey, Aman.
Hey, what's happening?
All right, so we heard, let's start with resource-based policies. And why are they called resource-based policies?
Yeah, absolutely. So first of all, glad to be here. My name is Aman. I'm a DynamoDB solutions architect. I'm based out of Dublin. Been with AWS a little under 7 years. So
you say that like you're new.
Was that?
You say that like you're new, just a little under 7 years.
Yeah, I mean, just shy.
You know so much about the service. You've worked with the service for a long time.
Yeah, I love trying to sneak on the engineering folks and see what they're building every day on the service. Try to break it. Try to use it as much as possible. Find out every nook and corner about it, and at the end of the day, share that with customers. So that part I certainly love. Yeah. So resource-based policies, right? As you know, Ashwin was able to share a lot of info and context on provider context on security. It's basically the feature allows you to define access policies for your table, which is your resource, and so you can go really fine-grained on I need to perform I need to allow this particular identity or particular IAM role get item permissions, which we know is a single item read operation on DynamoDB, or I need to allow this particular IAM role only to write to the table but not read it. So all of these things you can really go fine grained, but the main part, the USP is essentially you can govern that on the resource level. So
Right.
as an admin of a DynamoDB resource or a data team, I can be like, this particular team can only access the data science team, which Jason is part of, can only access this particular table and can only perform a set of operations only if these IAM conditions apply. So it
Okay.
could do a number of things, saying I can only restrict access for a particular IAM role, or I can only restrict access if for the particular IAM role access is made through a particular VPC, and so on and so forth. So I can do loads of things, but I can govern all of that in a single central location, which is my DynamoDB table.
Right, on the table or the stream or an index.
Absolutely.
The resources.
Yes. So
I
it could
think
be
of
index or the stream.
I think of it like you can do left to right or right to left. So the left to right is an identity based, where you give this role or something the ability to do things. And that's all we had before this. So I could have possibly 1,000 different roles that all were granted access to this table for their particular needs, but there was no one place to look at it. Now I can, instead of that, or maybe in addition to that, put on the table itself, I would like to be seen by them, deny this for everybody, deny this if this. Now, what happens if I have left and right, both of these, in the same account? How is that resolved?
So as long as the right, which is the resource, doesn't say that access is denied for this particular IAM entity in the same account, as long as that IAM entity has permissions, which is the left part, we're all good, right? We're golden. And this is the scenario for being in the same account. You may be familiar with S3 bucket policies, right? It's essentially the same concept. I can govern what a particular IAM entity from be the same account has access to my S3 bucket. I can either do it on a bucket policy level, or I need to provide that IAM entity, which is in the same account, access to perform S3 gets, puts, and operations as well. So it's pretty much similar to that. Think of it. Think of resource-based policies as a DynamoDB feature, which is exactly similar to S3 bucket policies and all the fun that comes with it.
So I could use just the right to left. The table says someone can do it, and unless that person's denied, they can do it. The identity is denied. Or I can have the identity say, unless the table denies it, it's allowed. So it's kind of the denies win, as they do in most circumstances like this. But if left or right, either one says it's okay, then it's okay. And that works. And yeah, I found that very convenient. Instead of going around and saying you and you, I just go to the table and say these people. It was like one stop shopping, one instead of 5. All right. It's different though when it's cross account.
Yeah, absolutely.
How does that work?
The cool part is that it really simplifies cross account, right? So now before resource-based policies, I would need to perform multiple steps, as Ashwin alluded to earlier. You perform your assume roles, you manage 2 different roles in different accounts, and then you basically assume role and perform actions when a cross-account setting. With resource-based policies, it's really simplified. So now if both sides agree, right, but both sides need to agree, which is the resource itself should allow this cross-account IAM entity to perform an action, but the cross-account IAM entity must also have permissions to perform actions on the cross-account DynamoDB resource. So both need to go hand in hand in order to support the cross-account scenario.
That makes sense. So I can open my table to you in a different account, expressly with an ARN that includes your account number. But that's not enough, because maybe your admin in your account wants to say, what do you mean he's accessing Jason's table? You have to be granted an ARN, using an ARN to my table. It says you're allowed to do something against my table. And if both sides agree, no more assuming roles in that dance that you had to do before. It just looks, this is pretty fun because now I can make, for example, a big table and say, hey, you want to do performance testing? Bang against my table, and I don't have to help you make a table in your account to do some performance test, right? I can, who pays?
Absolutely.
Who pays? If I do this, if I make a big table and you do a performance test, do you as caller or me as receiver of the table pay?
You pay because you have the resource itself, right? You have the DynamoDB table, and the DynamoDB table, in essence, is receiving the traffic, is performing, is processing the reads and writes. So that's the owner.
I had a feeling you were going to say I paid.
You always pay when we're together.
Well, yeah, it makes sense. Yeah, and when we're at dinner, who pays them on? All right, so this is good. Now, I have another guest I want to talk to. Yen Trey is an AWS serverless hero who really right after the release wrote an interesting blog post talking about, okay, so we made cross-account DynamoDB access easy. Why would you want that? That was his question. Hey, Yen, I wanted to ask you, like, so now that we've got this thing that makes cross-account easy, what's your opinion as someone who uses DynamoDB, doesn't work at AWS? AWS serverless hero is a title you get if you're really heavily involved in AWS but don't work at AWS. What are you thinking? Why would I want to do cross-account access?
Yeah, that was the question I had initially as well when I first read about the announcement. So I actually put a blog post together. I don't know if you guys can see my screen just yet.
Yeah, sure. Share the blog post. Let's walk through it.
Okay, cool. All right. Let me know when you can see my screen.
I see.
Yeah.
Okay, cool. Yeah, so the question I had was that, okay, if you can do cross-account access to DynamoDB, what's stopping people from breaking all the service boundaries when it comes to microservices? So instead of going different services, going to any of the services data through the API, you can just go straight to the database. And that's obviously a bad idea when it comes to designing service boundaries. And I thought, okay, that's what we're going to have with service resource-based policies and this easier cross-account access. But after initially thought about this, and quite a few people actually told me about a few valid use cases for doing this kind of cross-account access. So I thought that maybe I should document it, hence the blog post.
Yeah, you start with don't do this. All right. And
yes,
you could block
exactly.
it, right? The resource-based policy on that service C can say, if it doesn't open it up, no one's allowed. And it can even expressly block
Absolutely.
service A from doing the naughty. Got it. Perfect.
Yeah, absolutely. And also one thing I didn't capture in this blog post, which I talk about in a different blog post, was in fact, within the same account, you can also use a resource-based policy to block any traffic from outside of a VPC. So this may be relevant for like enterprise environment where there's regulatory requirements around the data access. So you only want people to access your data from within a VPC. And before you could only do this with service control policies. But with resource-based policies, you can now do it quite easily by just configuring that in your into the service C's account to say, okay, for this bucket, for this DynamoDB table, you can only access it from within a VPC within my account, or in this case, you can also open it up to other accounts, but specific accounts that you want to open the access to.
Right. Yeah, that is a cool feature. The table can say you must access me over a VPC.
Yeah, this is something that comes up quite a few times, especially when I'm working with enterprise customers. Things like OpenSearch, RDS, you can do that relatively easily, but you couldn't do that easily with DynamoDB before. But now you could with resource-based policies.
Right.
And so,
I just wanted to add that
sure.
With cross-account, that is defined by the resource owner very consciously to decide who the zone of trust is. There's also access analyzer that can come in later and scan for those cross-account findings and alert the administrator of those findings so that the admin can go back and look at the policies for least privilege permissions.
Okay, nice. That's cool. Yeah, so I collected a few use cases that I thought actually maybe valid use cases for doing cross-account access. Things like quite a lot of people have got ETL pipelines that need to collect data from a bunch of different tables from different services. So that seems to be one area quite a few people say, yeah, this kind of cross-account access will make it a lot easier. And of course, from the services, you would just open it up for that ETL pipeline account that allows them to access your data without having to go through an API and do a lot more expensive API calls to API gateway and Lambda functions and whatnot, just to collect all of your data. Another one, which is something that I've come across myself as well, is when you need to migrate from, say, a monolithic setup where you've got everything in one account. And I know it's AWS best practices to move to a multi-account environment. And personally, I like to go to a setup where I've got one account per team, maybe even per service, which means that I'm going to have data initially all in one account, but I want to end up in a place where every service got their own account and they can have their own database and so on. So during that transition, you're going to need to have some way to be able to move some feature into a new service or a service to a new account, but still be able to access the old database in that previous account until you finish the transition and move everything over to the new account. So while you do that, this cross-account access is going to be, it's going to make things a lot easier for you. I think quite a few people who work with the clients, especially large clients, who started life with everything in one account, run into this kind of problem before. And so I think this is also a very good case for using cross-account access. And I think you guys mentioned earlier in terms of resource-based policy, giving you another layer of control in terms of, say, InfoSec wanting to say, everyone should, for example, InfoSec can apply the resource-based policy on the table to say, all the tables can only be accessed through VPC and deny any traffic outside of the VPC. And so you can allow the application team to focus on the identity-based access control. But then someone else can then also come in and say, okay, we want to tighten it down so that and deny any access from, say, outside of VPC, and that way you can have the InfoSec being responsible for meeting compliance requirements, whereas the InfoSec, the application team, the product team can focus on the things that they are doing to enable, say, their Lambda functions or containers to talk to their DynamoDB tables. And so you got this different parts of the equation. So if it's in one account, then I think, like I said before, anything that's in the resource-based policy and identity-based policy, everything goes. But if it's a cross-account, then it's only the things that are on both sides. That's just the bit in the middle. That's what happens when you have a cross-account setup.
Yeah. Left hand, right. Yeah, like I really like the idea of it's a read-only table because I denied all write permissions. And I look at the table like, yep, that's read-only table. Not because every identity-based policy never included a write, but because the table says no one can do a write. Therefore, no one can do a write.
Yeah, so that would be a really useful case for things like when you're doing the ETL pipeline, for example. You got your ETL pipeline running in a separate account, and in the service account that owns the table, you can say, well, this account says that they want to have a read and write. Maybe they're just being lazy and just ask for admin or star. But on the resource-based policy on your side of the fence, you can say, okay, ETL pipeline account, you can ask for whatever you want, but I'm only going to give you read access to my table, so you can't accidentally write stuff to my table. So you can then lock it down on your side.
Well, I like that. They're like, I'm admin. You're like, no, you're not. You get this. All right.
You wish.
And you need to change just the table name with the full table ARN of the cross-account table. That's about it.
Yeah. And I think you guys mentioned earlier, I think I should mention earlier that sometimes enterprises often need to share data between different partners. I think you guys talked about who's going to have to pay for it when you have those sharing data with external parties. But again, this is something that the resource-based policy is going to make it a lot easier when you're working with partners who are also on AWS. So you can open up your table with just the right permissions so that they can access your data more easily. And I think the last one is really interesting because this is not something that I have actually come across until I brought up the dangers of a cross-account access for DynamoDB. And I think this is a pattern from what I'm told is very commonplace within AWS and maybe Salesforce and a few other really large companies, whereby I think the InfoSec teams, they only trust the account level, the account boundaries. So when you have a global service, you want to deploy to multiple regions, every region takes its own account, which means when you need to replicate data across multiple regions, you can't just use global tables. You have to, sorry about the noise in the background, you can't just have a global table do that for you, and instead you have to write data across to multiple regions, in this case, doing a cross-account assume row to the other accounts in order to replicate that change across to the other tables. So this is not something that, again, not something that I've actually had any personal dealing with, but I imagine you guys must have experience with this in terms of some of the challenges that comes with doing cross-account access for a global service like this.
Yeah, that's a deep subject. I might message instead, but you could definitely do it now if you want to go cross-account with direct writes.
Yeah, and it's sort of make it a lot easier for that.
Sounds like you have a fire alarm. I don't know what that background noise is, but maybe I should let you evacuate your building.
It's okay. It's okay. I'm in a library, so like a study point in a library.
All right. I think it's time for a demo. Thanks, Yen, for coming by.
Thank you, guys.
I'm going to switch it to you to show us this in action.
Yep, absolutely.
Let's share a screen.
Just trying to share my screen now. Okay, here you are.
Got it. We see it.
Right. So, we do the typical cross-account access that we've been talking about so far. So I definitely need a DynamoDB table in my account A. And right, I have my table created already. And now it should be active. As soon as it's not, it is active, right? So now I should go on and create a new item on that table as well. This is the item that we will later try to read from the cross-account role.
Okay, so set the stage here. We're making a table. We're going to try to read cross-account.
Yeah, absolutely. So my DynamoDB table would be in a single account, account A, and then I would go ahead and use another account, account B, which might have my applications. And in this case, it would be a Lambda function. And that Lambda function, and so now I have just switched to Lambda on account B, and that Lambda function will have a small script to basically read the data from the cross-account DynamoDB table. And that's the item that we'll go ahead and read. And basically, if you're talking about the both left and right use case again, right? Left and right need to go hand in hand for security, which is important. So I definitely like the experience that I'll be able to demo now. So I go ahead and finish my.
So we're making a Lambda function. We made a table. We made a Lambda function, but we made the function in a different account.
Yes.
That's the main thing.
Yeah.
And this would normally be hard now.
Yeah. Normally without resource-based policies, I would need to assume a role, create a client, assume a role in account A, which has my DynamoDB table, and then perform session token, get temporary credentials, all of those things, and then do the real thing, which is my business logic. But in this case, I go ahead and initiate the DynamoDB client, which is the Python Bodo 3 client, and say create a client for DynamoDB. And I'm still in my account B, so this is not the account that has the DynamoDB table.
Okay. So we're in B. We're going to try to access the table in account A. I'm going to guess. It's always fun to demo security. We like a movie. We need a big denied to flash on the screen if it doesn't work. What are we going to get if it doesn't work?
Absolutely. So, as expected, or we should expect an access denied in that case, because if you have, I haven't really added any permissions that allow access for this Lambda function on the DynamoDB table, which is cross-account, and I haven't even allowed resource-based policies on the DynamoDB table to allow this particular Lambda execution role. So, I haven't done that stuff yet, but the expectation should be that we get an access denied.
You're going to do a table name, which is interesting because it's cross account. So instead of a name, it's really an ARN. And we just ClickOps this. You can definitely CloudFormation and CDK this kind of stuff. And now it's a lot easier because you just, as long as each side has the right identity policy and resource-based policy, it works.
Yeah,
that's it.
And both steps go hand in hand, and both are required. Right? Can't just have one. So I go ahead and create a test event. I don't really care about the test parameters here. So
All right.
I go ahead and
I feel lucky it's going to work, right?
Absolutely. It's going to work as expected.
It's going to work as expected, as in it didn't work.
Yeah, as an access denied. And that's purely because, I haven't allowed any access on the DynamoDB resource.
What's it saying? What's it say there in fine print?
It says here, because no resource-based policy, if I'm able to get to the message.
No resource-based policy
allows
it.
Yeah.
We're hinting you. Like,
Absolutely.
You know what to do. No RBP allows it.
Yeah, I love the message is very explicit. It says exactly what you need to go and figure out.
Right. All right. So into RBP we go.
Yeah, we're back in account A, if you haven't noticed. And then I go ahead and create a resource-based policy for this particular table. I need it to provide get item access. And I try to copy the ARN.
Right, because now instead of table names, if we're going cross account, everything's an ARN.
Yeah, absolutely. And it was always an ARN for the resource itself, or the principal, sorry. So my Lambda execution role ARN is what I would use here. And then for the resource itself, I would use the DynamoDB table ARN.
Okay, so this function is allowed to do a get item on this resource table. So now we have granted. We have done a right to left grant.
Yeah, the right part exists. I
have a feeling I know what's going to come next.
Yeah, I feel the left part we haven't still.
Yeah, we haven't done the left. So what happens?
But I'm expecting a different error message this time.
I've never been so happy to see an error message.
Again,
because no identity-based policy allows it. Boy, they're really hinting at you, aren't you? Good job, Ashwin.
There you go. The handshake is really important there, isn't it?
Right. It's like, okay, so now we know what to do with this.
Yeah, I go to my Lambda execution role, and clearly it only had permissions for the standard policy that has access to DynamoDB, but in the same account. So I need to explicitly provide the left part, which is provide the Lambda execution role access to the DynamoDB table.
What's the video?
Oh, we have it.
There's the video back.
Okay, here we are.
Make sure we get to the good stuff.
Yeah. Right. So this is my Lambda execution role. I created an inline policy and provided it access to get item.
This is the left to right.
Yeah, exactly. And now we have the left to right and right to left both done. We have the handshake. And so I do expect that this time we go through all the way. Oh, there we are.
If you do right to left, you do left to right, cross account. It's that easy. No roles assumed. No roles were harmed in the making of this video. And now we've got it. So now if I were to want a performance test against a table, I could. You grant me the various read-only calls I need. I can make myself admin or attempt to, but it won't matter because I'll only be allowed to do what you told me I'm allowed to do. And now I can do a read test. I can have your table be my learning playground to do something against it, all that cool stuff.
Yeah.
That was cool. I like that. And yeah, all this stuff is supported in infrastructure as code. It's easy to do now because so long as IAM is configured on both sides.
Yeah, it has
got everything's still IAM, but now it's just an easier handshake to do. All right, for the second half of the show, let's talk about PrivateLink. And
absolutely.
PrivateLink was about I have an on-premise context and I want to access DynamoDB and I want to do it over a VPN or direct connect, right? Because DynamoDB has a public endpoint. I could always access it, and it would always be HTTPS if I used HTTPS, but a lot of people want to access privately. And I remember that VPCs, I could do this before with a gateway endpoint, right?
Yeah. So DynamoDB does have the public endpoint, right? Which is a public IP endpoint, which is super convenient, works everywhere. You can access the internet, but some people want to go over the Amazon network, so you use the gateway endpoints for that, right? And gateway endpoints for the VPC. So essentially, gateway endpoints work by taking the public IP and just routing it special onto DynamoDB. For this, your application must reside in the VPC, and that's important.
Gotcha. Yeah, because the gateway, it's just, you do a DNS lookup, you get the public IP, but the gateway says, oh, I know that IP address. I'm going to route it over Amazon's network privately, and you get it. It's easy to turn on, and you get more security, probably more lower latency. Lower cost, because now you're not going on the public internet, right? Look at Ashwin.
That's a really good point, Jason, that you mentioned.
So VPC, right?
One of the benefits of PrivateLink is now customers can choose their flexibility around low-cost private connectivity. So if they have 5 in-VPC applications and 5 on-premises applications that need to connect to DynamoDB, for the in-VPC applications, they can continue to use the gateway endpoints because traffic is free. And for the 5 on-premises applications that need to, let's say, maintain compliance over the private network, they could configure PrivateLink endpoints. And there, obviously, AWS PrivateLink pricing applies.
Okay. All right. So the challenge always was, if I'm on-prem or on my laptop, or let's call it on-prem, it's a fancy word for my laptop for a test, and I want to route over the VPN or direct connect, I could have done it before, but I would have had to do some networking things that are beyond my skills, probably me as a person, right?
You'd have proxy servers, firewall configuration on premises, trying to contain your traffic within the private networks. So that was the main challenge, infrastructural challenge.
Like, I don't want to do that. So what do I do now that's within my capabilities as a database person? How's PrivateLink work for me?
So PrivateLink provides private connectivity, as Ashwin mentioned. So you have your on-prem application, which is your laptop right now, and it can get to an AWS VPC using Direct Connect or VPN, right? That still exists, still was there before. Everything is good. And what happens after that is, once you're in the AWS VPC, you can get to DynamoDB through private IP addresses, and these private IP addresses is what PrivateLink provides you. These private IP addresses are part of your VPC. So even though you as opposed to gateway endpoints or the public DynamoDB endpoint, you get a custom DNS name, right? You get a custom endpoint that only resolves to IP addresses in that particular VPC.
Right. So it's a public DNS endpoint that gives a private IP address, which is in my VPC. So when I use it, it naturally routes through the VPC for me, but I have to change my code, right?
The code remains the same, except for the endpoint. Instead of pointing to dynamodb.region.amazon AWS, now I do use that custom DNS endpoint, and that's it.
Okay.
Everything else, the code doesn't know what's happening, where the traffic is going, right?
So when I get my endpoint, when I get my client, I use the DNS name, endpoint equals DNS name of my PrivateLink. That's it. The code doesn't have to do anything else. If I didn't do that, if I just said the public endpoint, then it goes public. If I do the private, it goes private. That's it. I can do this. I am capable of changing a line of code.
Yeah, and in fact, you can have both, right? It's not that gateway endpoints are going out of the picture. You can use both gateway endpoints and PrivateLink in the same setup, where all your in-VPC applications can access DynamoDB through the gateway endpoint, and the on-premise applications will use this new shiny PrivateLink endpoint to connect to DynamoDB.
All right, I like it. All right, I think we need a demo.
Yeah, let's do it. Right.
So you're done. Your dog doesn't like private link. It's growling. Hello, doggy. Needing some love.
You know, it's not a meeting if the dog doesn't show up. Yeah.
Possible since COVID, anyway.
Yeah, absolutely. So here's a setup that I will be demoing, and in this case, you know, my local machine is my my on-premise application.
Okay.
Particularly to avoid any connection drops, I'll be using an EC2 instance in a completely different region and network to emulate my local machine or my on-premise application, and it will connect to AWS VPC through the VPN connection, and then through to DynamoDB using the PrivateLink endpoint.
Okay.
Right. So let's go ahead and first create the endpoint itself. So I'll head to the VPC console because that's where my endpoints are available, and that's where I'll create the PrivateLink endpoint.
All right.
So down the list we go, and there's endpoints. And now we see that we'll go ahead and click the create option. Probably zoom out so that it's better. Right. So go to endpoint creation, and you will see here both endpoints exist, right? You can create an interface endpoint and a gateway endpoint in the same VPC and so on and so forth. But in this case, we'll create the PrivateLink endpoint, which is the interface endpoint.
Okay.
So I'll tag it to my VPC in question, where I have where I need the on-premise connectivity. And so I'll assign subnets and availability zones within that VPC, security groups as well, because security is important.
Making an IP address in your VPC that actually goes to Dynamo, right?
Absolutely. As simple as that.
And we got a policy here.
The endpoint can also govern what access should flow through it, who should be able to access DynamoDB through it, and so on and so forth. So I already have the PrivateLink endpoint created. So I'll skip this part and just show you that within the same VPC, I have coexisting endpoints in gateway and interface, with interface being the PrivateLink endpoint. And that's what we're
So if I'm in the VPC and I use the public name, it goes over the gateway. If I use the special DNS name, then it would go over PrivateLink, basically from the VPC.
That's the special DNS name. And if I use the gateway endpoint, I can see the public DynamoDB.
Wow. I see how I control it. Yeah. Oh yeah, there's the DNS name. That's only a mother could love. VPCE dash. Gotcha.
Absolutely. I need this for my application. I will need this for my application. So I'll go ahead and go to my my on-premise EC2 instance, which is in a different network in a different region. And so for that, I'll head to Ireland.
Representing you since you're over there.
Yeah, it's just good latency wise.
Okay, so we're going to go from an Ireland box to a Northern California box.
Yes.
Over a VPN.
And so over a VPN connection and PrivateLink, then straight to DynamoDB.
So you're making a Windows machine.
Yeah, I have a Windows machine here. I'll just download the remote desktop file. I have it already. I'll establish a connection with it, and I'll create a new session so that we end up in the on-premise box.
Okay.
Here we are. Let me just zoom out. And if you see that I have a VPN client there, which basically connects to the AWS VPC in Northern California. And so first I'll just disconnect through it. So I still have my on-premise network. I'm still part of the on-premise network, right?
Okay.
And just to show that I can still access the internet without any problems from my on-premise network, I'll just curl to fconfig. There I have a public IP returned. So, you know, as in this state, without being connected to the AWS VPC, I can access the internet, no problems. But this is a public internet, right? And
Okay.
so I would want to become part of the AWS VPC so that I can access the PrivateLink endpoint and simplify my private connectivity to DynamoDB.
All right.
So I have created a small script, and that script has 3 parameters. One is the endpoint that I want to choose on DynamoDB. Second is the table name that I want to access. And third is the region where the DynamoDB table sits. So the
Okay.
endpoint, the table name, and the region. And it simply performs a get item operation again, similar to what we saw on resource-based policies,
Right.
but it's a different value now, different table. But that's not important. The important part is that I'm accessing, I'm running it to access the PrivateLink endpoint, the table name that displays, and then my table sits in Northern California, so it's US West 1.
So you didn't set up your VPN, or did you already?
Yes, so I haven't, and I wanted to
Oh.
show that without being part of the same VPC or connected to that VPC, there is no way I can access DynamoDB using the interface endpoint.
This was
So-
another demo where it intentionally failed. That's security demos for you.
Yeah,
Watch my demo not work by design.
the past
That's
test,
what Ashwin wanted.
the past case is that it doesn't work when it's not allowed, right?
Right. Yeah, that's right. If
Access
it did work,
denied
that'd
is
be
good in
worse.
security.
Yeah. All right. So now you're connecting up to the VPN. So
Exactly.
basically, you're using an IP address that couldn't route anywhere. So that's why I just sort of said, I don't know where I'm going with this IP address. It didn't exist for you.
Yeah, and now
Now you
I'm
connect to the VPN. Hey, look at that.
Yeah, I'm part of the VPN. I've connected to the VPN, so I'm part of the VPC. I can access the VPC resources, and including the PrivateLink endpoint. I can access DynamoDB resources completely private using that private endpoint. And this is the DynamoDB table that I'm going to show you now that I accessed. That's in Northern California.
Right.
So here we go. That's the place table. And I have a bunch of items, but what I'm looking for is gonna be, I think it's foobar as the partition key value. Let me just confirm.
What you're showing here, Aman, is really key. Cross-region traffic with PrivateLink. It's a really cool use case.
Yeah, I mean, I wanted to emulate that it's on-premise, but it also happens to be cross-region, just because I'm using an EC2 there. But that's one of the key use cases as well.
Yeah, I mean, as our customers continue to expand with global tables across multiple regions, it just shows the power of how PrivateLink can help them maintain private connectivity across any region, literally, or inter-region.
Absolutely. And if it's a cross region or cross account, maybe you could also set up VPC peering between the VPCs.
There you go.
So all of those things can also be unlocked with PrivateLink. And yeah, that's with the demo.
What I think is really, usually when you get some new advanced feature, it takes a lot of mental space for me to remember it and remember how it works. What's interesting here is it's pretty straightforward. You can now put a policy on a resource that says who can do things with it. In the same account, I can be the one that grants access to it. Cross account, if we both agree, my account grants and the other account grants, then it's allowed in. And denies always win. All right, I got that. And here, I set up the PrivateLink. I get an IP address from a well-known DNS, changed one line of code, and now I'm changing how my networking is going instead of me understanding a darn thing about networking.
Yeah, and keeping all those compliance folks happy in the organization.
Yeah, I like it. And I think these two work together if you want to, right? Want to say just a quick word on that?
Yeah, absolutely.
They launched the same week. Yeah.
Yeah, so I can
together.
do cross account access, right, if I wanted to, and within the same setup. Let's say I have my application in a different account that needs to access this DynamoDB table completely privately. So one of the things that I will need to do, step one, is to establish private connectivity through and through. So I'll peer those two VPCs, right? One where the DynamoDB table, one belonging to the account where the DynamoDB table is, the other being my application. And the step 2 would be, in my application itself, I would need to provide the full ARN of the table, as well as, the left and the right go hand in hand. So on the DynamoDB side, in the other account, I need to provide resource-based policy access for that application IAM role. So 2 steps, simply. That's it.
Yeah. And there's a bunch that you can put in that resource-based policy. We talked about VPC, but there's even more than that. I don't know the full list, Ashwin.
Yeah, up to 20 KB, 20 KB being the max size of a resource-based policy for a resource. You could define multiple conditional keys that, strategically control the level of access you want to provide, fine-grained access control.
Right.
A lot of flexibility.
All right. I like it. All right. I think with that, we've covered the subjects pretty well. So thank you both for coming and helping explain this. Next week, we're going to talk about Amazon Aurora as a knowledge base for Bedrock for retrieval augmented generation. One of the main things you do with Gen AI is RAG, and this is how Aurora can be used to support RAG. That's next week's subject, and I'll be back in 4 weeks. All right. Thank you both for coming. Thanks everybody for sticking with us.
Thank you, everyone.
Thank you.